Alright, good morning everyone. Okay, so let's go ahead and delete that. That will be for later. Happy Friday! So let's go ahead and start this morning with some Leet-code and Code Wars. So let's go ahead and do some Code Wars. Alright, so we're going to complete the solution so that it reverses all of the words within the string passed in. And words are separated by exactly one space and there are no leading or trailing spaces. So the input is going to say the greatest victory is that which requires no battle and should return battle no requires which that is. Okay, so what it's saying here is that we're going to receive a string of characters. So we're going to receive a string of characters. And then we need to reverse the string by words. So we're going to receive a string of words and spaces, no characters, so no exclamation point or anything like that. So there are upper and lower cases to consider of words and spaces, upper and lower cases. And then we need to return the string, return a string back by reversing the string by word. So I would expect to see like something like hello world, and this should return back world hello. Let's see. So what I'm thinking in my head, a lot of possible solutions for this. Oh, another example I just want to bring up, something like the dog jumped, and this will return jumped dog the. So my understanding of this is that it's gonna reverse like this. We're not reversing any of the word. We're grabbing the entire word chunk by itself. And to distinguish what a word is the space between them. As you can see, that's how you're going to distinguish what is a word and how we're going to go ahead and separate it. So this one right here, let me charge my laptop. Okay, so this one right here, we're going to say, what is it? Okay, so brute force in my head is that we're gonna go ahead and initialize an empty string. And that we're gonna initialize an empty string, not reverse, but we're gonna go ahead and iterate starting from the end. We're gonna iterate starting from the end. And then check if it is an empty space. That means we know that we're at the end of the word. And then we'll add the entire chunk, add the word to the empty string. Else, what we're going to do is keep incrementing until we hit that empty space to grab the entire word. And then when you add word to the empty string that we initialize, we'll go ahead and return the string back. But adding strings to strings, since strings are immutable in Python, that would definitely be time of O(n) squared, because we're creating each new strings every time. So that would definitely be O of n squared. Space-wise, it will be O of n, because we're creating a new string in the background every time. And by doing that, that will definitely create n is for n amount of words that we need to iterate through in that string. Another thing in my head that I'm thinking about, instead of using this string method, let's go ahead and use an a list method. And what I mean by a list method is that we're going to go ahead and split the string by spaces. And then we'll go ahead and initialize an empty array, and we'll go ahead and add. We're gonna iterate from the end of the string, add to the array, and adding to the array, since we're always adding at the end, it's gonna be O of 1 time, since we're appending at the end. So we're gonna add to the end of the end of an array. And then what we're gonna do is join back by strings. We're gonna return by joining back by strings. In doing this, time will be O of n, and space-wise, it will still be O of n for n amount of words we have to iterate through. But doing the O of n operation, at least we're just creating the list in the background, and we're iterating through every single n amount of words in S. So, and I know that short, if we go ahead and what's the right word? Because Python is really good at making items not verbose. And I believe we can go ahead and use the slicing method for this. And then what we're gonna do, excuse me. Bless me. What we'll go ahead and do is we can split the string and then slice. We use the slicing method, and reverse. And you can reverse it. So we're gonna say return s.split. So we're gonna say s.split on spaces dot return. Make sure print on s.split. And should return a list back of words. Perfect. And then what we're gonna do is print. So then we're gonna return s.split on -1. So what this is saying is that we're gonna go ahead and join it back together as a string. As you see that when we did s.split method, it turns it into a list, and we can go ahead and reverse it like this. Oops, that is my fault to go ahead and add back the space there. And by doing this, it's still time is O of n operation, space-wise is O of n amount for, since we're using a list, O of n amount for n. We're doing this operation for n amount of words in S. And space is that we're gonna go ahead and create that. We're gonna go ahead and create that array, we're gonna go ahead and create that list in memory. So n amount for list in memory. This is what I'm gonna go with. Okay. Oh no. And ready to get pushed. It's a bit nippy this Friday. Oh yay! Okay. I love reading other people's solutions just to see where I stand. So this one is saying yep dot join, and we're gonna do string dot split. Oh yes! Okay, instead of using the slicing method, there is a reverse function. That is right. So you can do return by space dot join or dot join, and we're gonna say we're gonna reverse whatever is in s dot split, and we're gonna split by the space. I see. Pretty cool. I wonder if anybody did like a for loop. That's what I want to see. Okay. Yep. Okay, so you're gonna go ahead and say that for every string in the split. We're gonna ahead and add in the word. That is true because when you split it out, it grabs all of the words and then you can just go ahead and add it to the end. I like that. Pretty cool. Pretty cool. So let's move on to another one. Okay, let's go ahead and read this. So we're going to take two strings. So we're going to go ahead and take two strings, S1 and S2, including only letters from A to Z. Return a new sorted string, alphabetical, ascending the longest possible, containing distinct. So we're going to take the longest. Okay. So we're going to receive two strings of lowercase letters with no spaces. We need to return a new sorted string containing unique. Another way to say it is definitely to say containing unique characters. So we have an example of A, B, C, B, E. And then we have another example of B, 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 I. Okay. And then so our unique characters here are, since we only want one unique characters of each, we're gonna say A, B. So we're gonna get the first. So the way that I think about this right now, brute force is that we can have a pointer on each, and then we can like, hey, compare A to, hey, does A and B look familiar? Are they the same letters? If they're not the same letters, let's go ahead and add it to the string. So as you can see, A and B are both not the same letters. So let's go ahead and add it to the string. And then, but doing that, brute force. Let me just write down my brute force. Brute force, you are going to go ahead and create a pointer in the beginning, in the first char of each string. Compare if the characters are the same. If not, add to the output string. Else, increment and check out. I'll keep incrementing and check out the next string. And then what we're going to do here is return the output string. Optimize. How I think about optimizing this is that, so since we're looking for distinct letters, that clues me to think about using a set. And when I think about using a set, I want to go ahead, as you can see, I'm going to use a set for each string, because as you can see in our example here, there are multiple A's, there are multiple B's, but how can I condense that so I don't have to do double the look? Because if for here I would have to go back and look like, what if this has an A and then my pointer's over here, but how does my pointer know, hey, A exists right here? So the way I think about it is create sets for both string A and B, and then we're gonna go ahead. I'm almost thinking, in my head I'm thinking, why can't I just create a set for both A and B? Therefore, we're already concatenating I want to go ahead, let's just create this one big A plus B together, and then from there create this set, because you can still do that too. And then creating a set, I think you should be able to do that. Let me just double check. Set Python, because I think you can definitely add A and B together with two arrays. Yeah, I think I can do with 2 lists. Hi, Elder. Long time no see. How are you? Using the union method. Set 1, set 2, set 1. Oh, okay. So this is what I'm definitely thinking with the union method. So we can use a set constructor. And to print out only unique characters, we're going to go ahead and use the union method. Happy Friday, Elder. How you been? Long time no talk. We'll have to catch up soon. Let me know your things for May. Let me know. Set 1. Oh, I think I have to import it. I think I have to import set. Or should it be okay? We're gonna find out. I think I have to, no. Sets and maps. Sets and dictionary. Sets, dictionary should be there. Yum, you know what, Elder? I haven't had a fried egg in a long, long time due to the prices. I'm like, I think I'll be okay, but so, but once in a while, I do think about a fried egg though. So, oops, I don't know why I wrote import. Okay, set 1 equals, is it new set or set? Okay, yeah, set should be okay. Set of A1. Oh, yes, let me know. Yeah, I'll let you know too. I'm still thinking about, I think this year is definitely my year to go ahead and check out conferences. No. Honestly, I haven't seen, yeah, I stopped looking at egg prices. Have you ever tried a coffee for like egg Vietnamese coffee? Set 1 dot union of set 2. We're gonna return. Set 1 should equal a, oh, okay. So this is, when you use a set, it's an object of the unique chars. That's right, it has to be sorted. The line containing each taken. Return a new sorted string. Oh. Oh, that's so funny and weird how, yeah, my chat did that. Yes, I'll let you know. I do want to come. It seemed like a good time. Yes, the condensed milk. That's my guilty pleasure. I have the fin filter and I do make some at home, and sometimes I think about doing the adding the condensed milk. But I'm like, I don't think that's good for me. So, yeah. Okay, so I need to return it back in a string. And I want to return it back in a string, sorted. Okay, so in my head, I'm just trying to think. In my head, I'm just trying to think, is this the best way to do it? When I think about sorting, I think about the sorting function. I can definitely sort it. But is there another, what other ways have I learned how to sort? What other ways have I learned how to sort that doesn't make it O of n log n? Because overall, although I use a set, it is O of n log n. Yeah, because overall, doing this, time is definitely O of n log n. Space-wise, it is O of n for n amount of characters that we have to iterate through chars. Have to iterate through and log in. Worst case scenarios, because we have to sort. Is there a better way? I'm almost thinking some reason my mind is thinking about like bucket sort, but or no, I was thinking could use a dictionary of, but I don't think you need to use a dictionary. I'm gonna go with this for now, but we can always come back as well. Add it in 221. Okay, so I knew you could do A1 plus A2, but it's okay to learn the union method as well. I see. Set 1 or set 2. Interesting. A plus B is fine. Set 1 A1 plus A2. That's fine too. I see. Okay. Oh, interesting. This one's interesting. Okay, so we're going to define the alphabet. We're going to add them together. Y is our string. For X in alphabet, if X is not in S, then continue. If X, then add it to the current string. That's what it's saying. I'm just trying to think. I'm just trying to understand this person's code right here. How do you guarantee that it's... Oh, this one right here? This is very Pythonic, Elder? Well, one thing I'm trying to understand is how is it sorted? But then I guess it doesn't make sense because you're gonna go through each of the letter in the alphabet, and by starting off here first, then you're gonna check it in here. You're making sure it is in sorted order. But doing that in my head, will definitely be O of n squared. My head, I'm thinking the time complexity is O of n squared because since strings are immutable in Python, that would definitely be... right here. Yeah, yeah, like you said, it's very Pythonic. I'm definitely trying to write a little bit better with Pythonic way, but yeah, little as we go. So, any fun plans this weekend? Okay, so I definitely have been getting myself more involved with, in my head, system design with class objects itself. So this one is called insert, delete, get random, O1. And I like this problem, so let's definitely go ahead and tackle it. So what we're gonna do here is we're gonna go ahead and implement this randomized set. And what it does is it initializes the randomized object, and then in the insert method, oh, wait, sorry, have you moved yet? Hopefully it isn't too far of a drive for you, so that sounds like a good time. Sounds like a good time. So we're gonna insert, then so we're gonna insert a value. So here, let's initialize the object. I'm gonna write down my pseudocode first. Okay, so we're gonna insert an item. Return true, the item was not present. If false otherwise. What we're gonna say is that if the value is present, we can return false immediately. Okay, not too bad. Not too bad of a drive. So, hopefully traffic is good. Oh, fun. How's traffic usually in Texas? I was in Dallas once upon a time ago. I can't remember how long ago. 2? 3? But I was in Dallas and traffic didn't seem so bad. Not like LA traffic. Oh, oh, they're lucky. They get it. They oh, that's kind of cool. You have to show me all the goodies you got from Africa. Yeah, thank you for asking, Elder. I'm going up north. My cousin is getting married, so we'll be busy this weekend with family. So, oh no. Good thing, yeah. I see. Hopefully, it'll be nice to you this weekend. So, otherwise, let's go ahead and add the value that we're gonna return true. In the remove function, yeah. I'll let her know. Thank you for that. Yeah, so I'm excited. Yeah, she's getting married. I think she's a couple years older than I am. So, yeah, that'll be exciting. So, um, removes an item. So return true if the item was present, otherwise false. If the value does not exist, if the value does not exist in the, if the value does not exist, we're gonna return false. Else, what we're gonna do is delete the item and return true. Here, we're gonna go ahead and implement a random function that returns a random element from the current set of elements. It's guaranteed that at least one element exists when this method is called. If, or each element must have the same probability of being returned. Let's see, you must implement the functions with a class such that each function works in an average of 1 time complexity. Okay. Okay. So we're gonna use the get random function. I'm sure I should probably learn this, but I'm sure there are a way I can calculate this. But big shout out to libraries. I can use the random library and use the dot choice method to obtain a number from the elements. Okay, so let's go ahead. In my mind right now, brute force wise, I love using lists. So it right now it makes sense to go ahead and use a list. So we're gonna say self dot random list. I am trying to definitely be better with naming convention. I wanted to almost call it self.list. I know that's not the best way to do it. So we're going to do self.random list. And we're going to say here, based off of my pseudocode, I'm going to say that if val in self.random list, we're going to return false. Else what we're going to do is self.random list. Let's go ahead and append the val. So we're just going to keep adding to the end. And then we're going to return true after adding it. And then here, based off of my code, if val not in self.randomList, if the value does not exist, we're going to return true, false. And then what we're going to do is self.remove self.randomList.remove the val. And then the reason why I didn't return true first, sorry, let me finish that. The reason why I did dot remove method instead of dot pop is because the reason why I did dot pop instead of dot remove is because dot pop only works for the end of the element, or only works at the end of the list. So always that element at the end of the list. But who's to say that that value that we're looking for right now is always going to be at the end of the list? So dot remove method will be able to go ahead and do all of an operation to look for every value in the list. And then if it finds that value, it will go ahead and remove it. So that's definitely doing all of an operation there. This one, like I said, we're at the import the library. Import random. Here we can go ahead and say return random dot choice between the length of self dot random list. So let's go ahead and run it. Okay, so maybe it's not the length of it. By saying the list itself. Okay, perfect. But as it's stated here, everything needs to be done in O of 1 time complexity. And as you can see, adding to the end of the list of the array, adding to, I gotta stop saying array, but adding to end of the list is O of 1 operation here. And then, but removing, as I stated before, it is a O of n operation. Random dot choice, I think underneath the hood, it is O of 1. I could be wrong. Let me, yeah. Random dot choice, Python. Just to make sure. Random dot choice time complexity. Oh, it is O of 1, or to be more precise, it's equivalent to the big O random access time. Oh, so adding a list to it, it has O of 1 random access. I see. So basically don't use DQ. But with a list and a tuple, it is an O of 1 operation. Good to know. So our get random function here is okay. But my remove method is not okay. So let me just go ahead and save it. I like to keep a repo of my code. I like to see how far I've come, and I feel like I've come such a long way of doing code. Added and insert. Okay. I will keep these as is for the moment. And when I think about how to make things work in all one time complexity, anything that's instant, one data structure does come to mind where insert, get, delete. I'm trying to think of the other functions. Insert, get, delete. There's like one more function, but then dictionary is all of one operation for all of those. Because when you insert into an array, when you insert into a list, it depends if you want to go ahead and insert from the front or back, because they're two different time complexity. But if we're talking about O1 itself, it's best to go ahead and add an object to it as well. So let's go ahead and add an object. I'm just thinking about a good naming convention. Self.random object. What's a good naming convention for object? Self.random object. Okay, so that's what we're gonna do. And then the way I think about changing this up is that if val is in the self.random list, we're gonna return false immediately. Else what we can do is go ahead and insert the value in here. But also what we're gonna do is add the random object of random object. Okay, so what we're gonna do is set in the object itself, we're gonna go ahead and set it so the key is going to be random object. The key in here is going to be the key of val is going to be equal to whatever the index is from the self.random list index. If you're already in there, we're going to return false. Else what we're going to do is we're going to go ahead and say that the key value pair. So a good way to think about it is, okay, so we have so far a list of 1, 2, 3. The way I think about it is that 3 people are waiting in line right now, and the way I'm going to keep track of who's in line is 1, 1. Actually 1 is 0. Then we're going to say that 2 is 1. Oops. We're going to keep track. We're going to go ahead and keep track of their index position in that list. So that's what I'm going to do here. So we're going to say that for the value that's going to get inserted at the end, which is 3. Oops. Which is 3. It's going to be added at the end of the list. And then we're going to go ahead. The order of operations there didn't make sense. So we're going to say that we're going to go ahead and add you to the list. And then we're going to say, hey, your value is equal to whatever that index position is. Self.random list index position. Self.random index position. Append the val index position. Index? I'm trying to say the index position. Let me come back to it. Remove from doc. And then here, remove. Okay, so the way I think about removing, if the val's not in self.random list, we're going to return false, correct? Because if you don't exist in the list, let's go ahead and return false. Otherwise, if val exists, then we need to make this all one operation, we need to move the index position in that list to the end of the list. Then we can say pop. If val exists, move value from the middle of the list to the end of the list. So essentially swapping places, and then we can pop the value, and then we can update the index position in the map or in the dictionary. Update the index position in the dictionary to update index position in the dictionary for the element that we swapped with. That was swapped. Then we can delete the previous entry. Therefore, it would always have the current index numbers that exist in there. Yeah. Okay. Okay, so if val not in self.random list, we're going to return false. Else what we're going to do is say that last val is equal to self dot random list of the last index random list minus 1, and then we're gonna say element to move is equal to self.random to get an O of 1 operation. I was going to use the list, but that doesn't. To use the list, I still have to do O of n operation. So that will definitely slow the time. So to get that element that we're going to move, I'm going to go and look into that object instead to get an O of 1 operation. And to do that, we're going to say that you're equal to the element that we're going to move is equal to the val that we're looking for. And so we're going to swap places. I was like, can I start print? I want to print and see what I see. But is this a good place to print? Yeah, so because what I'm going to do after that is, okay, so here I'm just getting the elements first. After getting the elements, we are, let's see. After getting the elements, let's swap them. So self.random of list, you're equal of that val, you're equal to the element to move now. And then self.random object of the last val, you are equal to the last val. We're going to say the element to move. We're going to update the current existing number. And now we can go ahead and say self.random list.pop, because now we know for sure the item that we want to remove will be at the end of the list. And now we can say delete self.random object of val, and then we can return true. Okay. This one, we're gonna append the value. What we're gonna do is append the value. Let's see. Let me grab. Okay. After thinking about it, okay, so if we're always going to add values at the end of the list, that means that we know that we can assign the index position to equal the end of the list itself. So it would be length of self.random list minus 1. So this one should not fail. Did I? Oh, okay. The reason, okay, so I can just say -1 because that should be able to grab me the index position at the last one of -1. And what we're gonna do is in the object, we're gonna grab that. Yep. We're gonna say self. We want it to update. So in the list, let me draw it out. Okay, so I have it here. I want to draw it out like this. So let's go ahead and draw it out. Self.random list. We're going to draw it out. So say for instance we want 2 to be booted. So sorry 2, you gotta go. Okay, so 2 is deleted here. But we're going to switch 2 and 3. So I'm going to keep the original. I'm going to make another one. So we can see original. This one is, so we can see the original, and now we're gonna see the updated. We can say new, original, new. So we want the 2. So 2 will be moved with 3, 2 here, so that it can turn into 1, 3. And then 2 here has to be updated to our index position of 2. You're going to be updated to the index of 1. Yeah. Actually, 2, 1. Okay, so that's the case. We're going to say here, you're going to be, so we're going to say that, okay, so we're grabbing the last index of 3. And we're also grabbing the element that we want to move. We're also grabbing the index position from the element that we want to move. And then we're going to say that, from the list, from the list here, we're going to say, oh, yeah, no, I always wonder about Twitch ads. You know what they say about Facebook ads, that they're always listening? I was like, I wonder if Twitch ads are listening too. But the way it sounds like, Twitch ads are very random. That's what it sounds like. It's very random. Okay, so the index position in the list, we're gonna update that list index. We're gonna move that index position 3 and 2. We're gonna move and swap those. And then when we swap those, we need to go ahead. When we swap those, we need to go ahead. That's crazy, Elder. Oh yeah, I know you say you don't really watch too many Korean dramas, but on Viki, there's a website that I watch Korean dramas on. It's called Viki.com, and some of these ads are just, it doesn't pertain to me at all. I think I get a lot of car commercials for Hyundai, Toyota, and Honda. And there are other commercials that I'm like, Oh, this doesn't pertain to me at all. I just thought, yeah, I just think it's interesting the type of ads that they're trying to target with. But yeah. Yeah, I'm like I'm not in the market to buy any cars right now, so I thought that was kind of funny. I was like, I guess. Yeah. Hi, Chris. Good morning. Happy Friday. Okay, so this part right here is saying that this valve right here, you are element to move. Oh, I know. Who was it? I forgot his name. But then, yeah, I saw one of his posts about his ads. He was like, I don't even like do any of this stuff. So I thought that was so funny that the type of ads Twitters are giving you. Okay, so we're thinking O1 operation. O1 operation. It's easy to get the last O1 operation, and it's always easy to get the index position of the last list, because we know that we can directly go there and it'll always be O1 operation. And now I need to find the 2 index position, so it's easier to go and check in that map, or dictionary, dictionary. So it's always easier to go ahead and check it in the dictionary. And now in that list, we're gonna go and go directly to that index position, and we're gonna make it equal the last vowel. So they're swapping places, because we definitely want to keep everything O of 1 operation overall, because if I do any O of n operation at least once, that does make the whole time complexity O of n. I'm starting to get it. Okay, and then now we're gonna say that that last vowel is equal to whatever element. So now we're gonna say that that last vowel, its index position is always going to be equal to that element to move index position. And now we can pop it off in O of 1, delete it in O of 1. I get it now. I like to make little notes on the side as well. O of 1 time to grab the index position. That makes, okay, now I understand why, because I was slightly a little confused in the beginning when it stated I had to go into the map to find the index position. I was like, that doesn't make sense why I would go into the map, but now it does, because like our example here right now in our 2, we have to go through each item to find that 2, and that's an O of n operation. Versus if I go straight directly to the map, I already know where that index position lies, and that gives me that O of 1 operation. I see. Sometimes you gotta talk it out a little bit, and that helps paint the picture. Add it in, randomize it. I definitely want to, where our problem list. Okay, let's see. I want to do a really random one. Okay, well, not too random. No, I mean, investor ability random. Let Since this is my first time in a while, we're gonna go ahead and do some difficult. We're gonna do merge to sorted list. I haven't done this in a long time. So okay, so this is our linked list. So we're gonna merge 2 sorted lists. You're given the heads of 2 sorted linked lists, list 1 and list 2. So we know for sure it's gonna be sorted. So we receive 2 sorted, list 1 and list 2. So we need to return back one sorted link. When I say LL, it's gonna stand for linked list because that's a lot of things to write. So we're gonna return back one sorted linked list. The list should be made by splicing together the nodes of the first two lid. One thing that trumps my mind right now is splicing together the nodes of this first two lists. I don't know if you can directly use like a list splicing on linked list. I've never done that, but I get the concept of these merging two sorting linked lists. Let's go ahead and give you an example. So for sure we know that's always going to be sorted 2 and 3, and this is in the end of 3. It's going to point to null, indicating that it's the end of the linked list. And now we have our second linked list, list 2, list 1. This will be a 2, this will be another 2, and this will be 5. And then now we're going to do null. Well, let's make this a little trickier like this, because although it gives you 2 linked lists, we don't know if they're of even length as well. Although it states here, okay. So what we're gonna do is, in this one is that we're gonna go ahead. So what I expect to see for the output here is that we're gonna have a pointer on both of them, 1 and 2. And we're gonna compare, is 1 less than 2? If so, let's go ahead and add 1. So 1, and then it should point to 2, and it should point to the other 2. It should grab 1, and then it should grab 2, and it will grab 2 again, and it should grab 3, and it will grab 5, and it will hit null. Other edge cases I think about this, if list 1 and list 2 are empty, we can just return empty. We can just return an empty one, empty list. I'm trying to think, like, with the situation of it just being length of 1. I think if it has a length of 1, I think it I think it should be okay, because the normal code will go ahead and handle it all. I definitely don't want to write too much code that's doing duplicative work. So what we're going to do is go ahead and write out our edge cases are sorted in both non-decreasing order. Okay, so they could have the node values itself could have negative numbers. So that is something to consider as well. What we're gonna do is say that if not list 1 and not list 2, we're just gonna return an empty array. Otherwise, what we're gonna do here is initialize pointers. So we're gonna say current 1 is equal to list 1, and then we're gonna say current 2. So these are gonna be our pointers, and they're gonna start at the first node of each linked list. And I am just trying to think of okay, I'm just trying to think. I think I need to initialize a head, because ultimately at the end I'm gonna go ahead and initialize. I'm gonna return back a head, because we're gonna return back the beginning. While current 1 does not equal null, none, and current 2 does not equal none. Oh, it's been a minute since I've done linked lists, but this is what I'm thinking. So while they don't equal none, meaning they haven't reached the end of the list, we're gonna go ahead and say, okay, what we're gonna do is make it a head equal to none right now. We're gonna set it to none because that is our main beginner, and we're gonna say, hey, you're gonna hold, and we're gonna go ahead and link the other nodes right next to you afterwards. But we're gonna say that if current one dot val is less than current two dot val, right? Dot val, yep, dot val, which is part of the list node. We're gonna say that head is equal to, oh, just kidding. I started writing it like that. Head dot next does not write like that. We're gonna say that our current head right now that is none, it's gonna be pointing to if current one, because if current one is less than current two, because we need to make sure that it's in non-decreasing order, then we're gonna say that head dot next is gonna point to current one. So now we need to make sure that current one is equal to current one dot next, making sure that it's gonna point to the next node. Else we know for sure. Else what we know for sure then is gonna be current two. So we can just go. Okay, wait. Let me write this. I just figured it out. There's gonna be a flaw. Current two. So go to current two down next. Okay, so what I just realized when I was writing this is that, okay, so although current one and current two, let me picture this. Draw you a picture. Okay, so we can use my example right here, and I'm gonna say that head, oops, let me comment it out just so that it doesn't break. So we're gonna say head, you're gonna equal nothing right now, and then we have C1 right here. So here's our pointer hanging out here. Then we have our pointer C2 hanging out here. So what's happening is C1's hanging out, C2's hanging out, and then head has nothing right now. But I want to go ahead and continue my next one. So C1 is going to compare to C2. Hey, you know what? C1 and C2, who's the smallest one? So C1, you are smaller, so we're going to go ahead and add you, and then we'll go ahead and create your pointer. But head, and then head here will go ahead and point to the next one. Oh, sorry. In my head, I thought head was going to lose its pointer, but I think it should be okay. It should be okay. And then after everything of this, what we need to do after adding the current one, current two, head needs to move itself to create that pointer, because C1 will tell it to say, hey, we're gonna move on to the next pointer. Now we're gonna have to tell the head to move on to its next pointer. So we're gonna move down to the next node after everything. Well, it's been a minute since I've done linked lists. I think this is right. I feel like there is one more line, but I think this is it. Because after we add the nodes from current one and current two, head is gonna move and create space for the next node. There is a situation where, like I said before, there is an uneven length. If there is an uneven length and there's still one list remaining, we can just add everything else from that list over. This one will be if C1, okay, not C1, if current one, so that means that current one is still, I think I can just say if current one. I'm trying to say, do I need to say that? Is that too wordy? I feel like that might be too wordy. If current one does not equal none, meaning like you haven't hit the end of your linked list, then we'll say that head.next is equal to the rest of whatever current one is. But I think to be less verbose, I can definitely just say current one. If current one, then we're just gonna say that head.next is equal to the rest of the linked list. Else, we can say that head.next is equal to current 2. And then here, what we can do is just return head. I don't feel too comfortable about this. I think head is right. But what I feel like if you keep moving head, you keep moving head down the linked list. We lose head at the beginning of the linked list. So what I think I need to do is initialize head. We'll call it tail. Tail is equal to none and head is equal to tail. And then everything head. Whoops. I didn't mean save. Anything head should be tail. And here it should be returning head is equal to tail. And tail is equal to none. I think this should be returning dot next, because if I return head is pointing at none right now. But then I want to point to whatever the next node after head. So it should return head.next. No! Okay. It's a non-object. Okay, so what is my error telling me? So none-type object has no attribute of next. Tail.next is equal to current 2. Okay, so while current 1 and current 2, yeah, I think I can definitely keep it less verbose by saying that while current 1 and current 2, so the meaning that while truly and truly, we're going to compare the values and see who is the smallest one. Then tail.next, you're going to go ahead and point to current 1. Let me print out what tail has right here. If tail has anything. Okay, tail doesn't, let me, yeah, comment out everything else. Let's do some debugging here. Really? Bear with me, everybody. What I am gonna do is, okay, let's go ahead and print out what we currently have. Print head, current 1, current 2. Unexpected indent. Okay, there we go. There we go. Oh, it's not valid. Type error is not valid for this type. If not list 1 and not list 2. Hello? Yes, I do. No, I typically do follow a specific study plan because I do like, have, especially in the beginning, I feel, yeah. So I do a little mix of Leet-code 50 and also the, Leet-code, 95 or 75. Like, what is it called? Leet-code 75. The blind 75, yes, that one. I really like the blind 75. I like how blind 75 and Leet-code, they have it in sorted order. So you'll learn arrays 1 week, and then you'll learn 2 pointers, and then you'll learn the sliding window. Yeah. So I like learning it like that in a very specific week. How about you? How do you like to solve Leet-code? Return none. Okay, there we go. I was following suit of what this example was stating because it's saying that list 1 and list 2 are both empty. So we're going to return an empty list. But I guess it wanted me to return none instead. Okay, perfect. Okay. Okay, so none. So none and none, correct. List 1 right here, it is pointing to 1, 2, and 4. List current 2 should be 1, 3, 4. Yep, 1, 3, 4. Okay, perfect. So we are doing it right now. Then I should be going into each one, being able to access the val, and I'm gonna say that, hey, the next pointer, you're equal to whatever current one is stating. CURRENT tail.next, you're equal to whatever. Did I spell current wrong? Current 2 tail.next is equal to whatever current 2 is. Current 2 is gonna move down to the next slide or next node. So when we found, because we know that if this is less, if current 1 is less, let's add the node from current 1. Else, we know for sure that if this turns out to be a falsy condition, we'll jump into the else. In the else, current 2 should be added after everything. Let's go ahead and move our tail as well. Tail.next does not equal current 2. Tail.next does not. Is it because I said tail? Is it because I set tail to equal none? Oh, I know that in JavaScript you can initialize a null, and that you can point it to. So essentially here I'm saying that you're equal to null, but maybe what I need to do is turn you into a new list node. Okay, I should have spelled that correctly. That way it knows to connect you to. Wait a second, is that not how you initialize a new list node? Maybe I do a list node. Okay, okay, so this is something good to work off of. Okay, only 4 was added, so it skipped everything. Okay, so we can see that it never added. Head, I want you. Head, no, I think head should equal to this. Tail, you're equal to whatever head has. Because I think what's happening is I'm overwriting it. Nope, okay. Okay. Let's see why that is. Okay, why did a 0 get added? Was I subtracting anything? I don't think so. Okay, so the list node right here, I think that's what's happening. So this one right here is our 0. So this is what's happening. I believe you are our 0. And what's happening is tail is equal to head. And we're saying that You know what? I think these go back. Because I don't want this line from 43 to 46 to happen during the while loop. Because we should exit the while loop, because if one of them has reached the end of their linked list, then let's exit out and we'll just add everything else. No. Okay, so this is double added. I definitely think, I definitely strongly believe that it should still be head.next. And I do think that I did indent it right by saying that if current one is still, hasn't reached the end of the linked list, we'll add it. I think it's just the way that I added this. Tail is equal to head.next. I want heads and tails to be at the same place as well. I want heads and tails to both start off at the same place. And now tail's gonna move while head stays secure at the first node, because we need to return back that head. And I feel like, okay, so tail.next is equal to tail. Okay, maybe one more minute and now I'll have to look this up. Okay, because I'm saying that, okay, so we have heads and tails. So we created pointers on list 1, list 2. And then we created a heads and tails. Tail will move while our head stays at the first node, so we can be able to return back that linked list. And we're going to say that while Trudy and Trudy, they hadn't reached the end of the linked list, let's compare their values. So let's go ahead and compare their values, and if the value of this is less than this, we'll add the node from the first linked list, and then we'll move the node in that first linked list. Else we'll add the node for the second linked list, and then we'll move the pointer in the second linked list. After that, after adding it in, then we'll move it. And I did indent that correctly because we want to add it after we do our if else condition during the while loop. No, I feel so strongly about this. Like this is right. I feel like this is so right. I'm gonna have to look this up if you guys don't. I think this was in JavaScript though, but it's okay. Maybe this can still be applicable. Equals new list node. This is in JavaScript, right? Yep, this is in JavaScript. So essentially that's what I was doing. I'm just saying, okay, so essentially what I did was saying head, you are our new new list node. We have our tail that's connected to dummy, so the tail will keep moving. Current 1 is a pointer, current 2 is a pointer. If current 1 tail.next is equal to this, tail1.next, current 1 moves, and then current 1 else this. And then afterwards, I said tail.next. Okay, so you have to return the dot next. While list 1 and list 2, if it's less, we'll go ahead and add it tail.next equals current 1 else, and then we're gonna move it. I think, yeah, tail.next. That's my fault there. And then, oh, okay, so I'm glad that we took a look at that. And, okay, that's right. Tail goes tail.next. Okay. Yes. But doing this will definitely be O of n time. I could be wrong. You can, oh, yes, you can use recursion, but I haven't gone that far yet. Pointer. Oh, time complexity is O of m plus n. M plus n because uneven lengths of linked lists. So any that applies to lists as well. Anytime that you have an uneven amount of lists or linked lists, it is O of m plus n. Okay, we're so close, guys. We're so close. Okay. Yeah, thank you for coming to hang out today. Yeah, I gotta get the rest of the Friday going. So let's go ahead and have some fun and hang out with other people. Forget how this works. Okay, we click it. We're gonna go hang out. Thank you for coming hang out. Let's hang out another day.